other thing, just wait from the current process. So one option is the parent process is waiting. At that time, you can use the wait system library. The parent process is waiting for the response of the child process until the child process is done, terminate. Another option is, if you do not specify the wait, you can actually continue to work. Also, there is the way I already explained the last time. You can change the parentship to the kernel. Then you can actually exit or any other thing. That is the daemon process. That's different one. Also, there's another one, background and the foreground. We will see the details of the background and foreground with the practice in the next exercise lab. But the simply background, if you can use emphasize the symbol, when you run the program, which means so wait is the suspended. Okay, it's a wait, but the wait of this one, but at the same time it will be background. The foreground is the I'm keep working my job. Okay, that's different from the daemon, but there's a background process. This will be the child process will be background, and as a foreground, the parent process is going their job. So you can at the time use the wait, the system library, to wait the termination signal from the child process. Okay, so always we need to use the two systems. Mostly, mostly 100%, we need to use the both fork and exec together. Because of that, do I need to use both of them? So Windows use system library, create, process. It's combining both of them. Anyway, eventually we will use the fork followed by exec. Then why don't we combine together? So the Unix and the Linux system still use the separate system library, but this one use the create process. You will see variation of the fork and exec, like the vfork and the vexec, so much. So you can see the details, whether we can consider number of such a resource as a vector and so on. So you can see the details from the manual page. How can you check the manual page? Google it. Or in your Prompt operating system, there is a manual command, man, you will see during the exercise lab also. So this is how we can create the process. This is the most important part. Then, finally, you are able to. The programming example is very simple. We will see the example of the So, when we create during the fork, so except the code section, it will be exactly copied. Which means, if you just use the fork several times, what happened? Several same program running together. Number of processes will be created, but they are the same, identical. Okay? Only difference is ID. Okay? So, for example, I think that we have the example here. So, eventually it will be like this. So, this is the diagram to show the fork, exec, and wait. Exit means the system library, the gracefully terminate. Is end of the process. That the signal to the parents is the wait. Okay. So this is an example of the program to create. So fork. What happened? Copy this one. There is a new process. It's exactly same this. At that time, what about the PC? Program counter. What is a program counter? Location of the next instruction. Okay? So program counter is here. Then when you fork, there is another exactly same copy of this process as a child. And where's the PC? Same thing. Even copy the PC. So two processes is running same time. This time. Then let's say that this is a parent. There is another the child. So parent, their process ID and parent process ID is different. So PID of the parent process is what? It's a child process. For example, the parent current process is 10. Child process is 20. Okay? For the parent side, the PID is what? 20. And what about the child process? It's exactly the same thing, but PID is 0. Why? It's after until assigned, child process will not be created. Okay? After assign the 20, then this one is copied and the child process ID itself is the 0. That is a reason to identify. There are even though two copies of the processes, programming code using PID value. So parent, from the parent, the process, the PID is the 20. Okay? This PID is child process ID and assigned to the variable. Then finally it's copied here. Their process ID is 0. Because that PID is a variable, not the process data structure. Okay? This is a variable. So that is one thing the student confused. Okay? It's not the VLC, that is a program control block. Yeah, all the information about that process will be stored at the data structure. That is called the PCB. The PCB, inside the PCB, you have your own PID, PPID. But this is just nothing but variable. Okay? Return variable of the function. So that is a 20. So 20. So we can name this is not PID, this is a lead. Okay? Doesn't matter. This is just nothing but variable. And then the lead, this one does not have because it didn't fork. Okay? It's before the bone create, it happened. So value of the PID, lead of the child process is 0, which means even though there are two processes, okay, identical, how can we identify which one is the child, whether this one is the parent? Using PID value. If PID is 0, that means this one is 0. This one is 0. So we can then exe, which means load the new program. In case of the 0 means even fork error. We cannot find the resource. Okay? Then there is error and return. Otherwise, the other case is the positive value, so PID is 20, which means this is the parent process. Means I'm going to wait until child is done. So it's a wait. Okay? Then if the child process is completed, then this will be freed up and returned to the parent who is wait. And get the next child is complete. Continue or so if you follow this one, then get the input variable this. This will be what? Shell programming. All shell programming using the same mechanism. Very simple. What is the main job of the shell programming? Creating new process. Okay, so we can use this is the shell programming. Any shell programming use the same. This the program. So we can use just while loop. Okay, then input only this part we can get the input. Then plus we can add more the functionality. Okay. Somebody should let me know. It's after the 15. Okay, so this is a very important concept. What is the data structure of the process? How we can create the process. The next time we will see it's not less important but less important than this, but we will cover the other part, then continue, followed by the exercise. Okay, any questions? Okay, thank you, and see you on Thursday.